Okay, team, this is your first video on the existence theorems. So these are essentially facts we know about functions and graphs of functions, and they are usually presented in a way that makes them seem more complicated than they are. Okay? The thing you need to know about all three of these theorems we're going to cover in this little mini unit is that you need to prove that their preconditions are true in order to use them. Especially on the AP exam, they really look for that. Okay, so let's look at an example of a theorem, and I'll show you what I mean. So this is a non-math example to start. Okay, if you get good grades, you will get into college. Okay, so really the way to say this is like, I could simplify this just to say good grades implies college. Okay, so we're looking at the logic of this. The logic of this is that if I know that you as a student have good grades, I pretty much know for a fact that you're going to get into college, right? So this is an example. This may not be true in every single case, but this is the kind of logic I'm looking for here. So what I'm going to do, let's say I wanted to prove to you that you would get into a college. I'd be like, hey, here, look at your good grades. You're definitely going to get into college, right? The thing by that if here is called the hypothesis of the theorem. So the hypothesis of the theorem, it's a little bit different than how you've seen this word used in science classes. This is what we prove to show that the theorem implies. So the hypothesis, proving that implies the conclusion. Okay, so what we're going to be looking for, this is not like a unit about like calculation or solving problems. What we're going to be looking for is like facts that support our conclusion. So this is really about making an argument. And making an argument in math is usually about showing that a known theorem applies. Okay. Let's take a look at our first theorem. The first theorem is called the intermediate value theorem. And here it is. So you can pause and take a second to read it. And as you read it, don't panic, because it is much easier than it sounds. Okay, so the first part of this text is the hypothesis of this theorem. So this intermediate value theorem only applies if f is continuous. Luckily, we already know how to prove a function is continuous, right? We say the left limit and the right limit are equal to the function, therefore the function is continuous. Okay, so we already know how to show that this theorem applies. So on the interval a to b, so what this means is we have some curve that goes from, let's try like this, goes from a to b. And we don't care about what happens outside of this interval, but we know it's continuous within this interval. If n is a number between f of a and f of b, so this tells me that n is a y, right? So we'll say some number n. Then there is a point c in a to b such that f of c equals n. So that would be here, right? So this is a picture of what this is saying. Okay? And it's really not very complicated at all. I know that the rigorous presentation of it looks pretty complicated. Let me give you a sort of example of this, and I'm going to prove to you that it's not as complicated as it sounds. So let's imagine that you're looking for a friend of yours, and you know it is at Noble, and you know that they usually take the blue line home division. So you can get those two spots in your head. Even if you don't have the blue line, you're familiar with the blue line and the triangle and all that, right? So you know your friend is going to walk from the blue line, or from Noble to the blue line. What you might do, right, is you might go to that corner store that's like halfway in between them and Milwaukee Avenue, and you might wait. You might go wait in between somewhere, knowing that they have to pass that corner store to get to the blue line, right? So that would be like an easy way to find your friend. That's the same as this, right? This says if f passes from this point to this point, and there's some point in between, f has to pass through that point. So imagine that your friend is walking now along this graph from A to B. If you wait at n, some y value, they're eventually going to have to pass you, as long as that y value is from A to B. And the graph is continuous, right? Because I could easily draw something like this, where I have some kind of discontinuity in my graph. And then the intermediate value theorem like clearly no longer applies, right? Because if you were like waiting at this point, the function never touches that point. So that's why we need to show that f is continuous before we use this. Let's look at a couple of delta math problems. Okay, here's what we got. So notice it tells us that this function is continuous on its whole domain, and they hide a piece of this graph from us. So from -1 to 5 is hidden from view. So knowing that this is continuous, based on this intermediate value theorem, we know that this left-hand piece connects with this right-hand piece, right? So what we're going to say, before we even worry about this too much, we're going to say that because f is continuous, the intermediate value theorem can be applied. And these two things always go together, because the theorem only applies, that's the hypothesis of the theorem, right? The theorem only applies when f is continuous. Now, here's where it starts to look a little intimidating, to me at least. For any value k on the interval, there exists a value c where c is between two numbers, such that f of c equals k. And you're like, okay, what does this mean? Well, what we're going to say is that like any y value in this blank space has to be between the two y values that we see already. So k, if f of c equals k is a y value, so they're going to go with our two y values here, right? So k is going to be between 2 and 4. There exists a value c. C is an x value, so c is the x between -1, and this is easy to see from the way they drew the picture, -1 to 5. Okay? So we're saying that the theorem applies, and then we're describing where it applies. And this first set of blanks is your y value from these 2 points, and the second set of blanks is your x value. So pause, make sure you know that where I got everything here. Now here's the million-dollar question. Must there exist a value of c in the interval -2 to 5 where f of c equals 3? Well, 3 is between 2 and 4, right? So what it's saying is, essentially, if I drew a line here, I'll actually draw that line in here. It's asking, this line is at y equals 3. It's asking whether the function has to cross that line. And if the function is continuous, it obviously does, right? So we're going to say there exists a value of this c in the interval where f of c equals 3. And that's it. Okay. So there will always, as long as the interval matches what we set up here, and the y value is between the y value we set up here, there will always exist a value of c in the interval where f of c equals the value that we're looking for. That's what the intermediate value theorem says. Okay. Now, there are going to be problems, and let's see if we can find one here. So here's one. There are going to be problems where it gives you essentially the same thing, but notice, take a second to read it. It doesn't say that f is continuous anywhere in the text, right? So you're looking for that, and this is true in the AP exam as well. So on the AP exam, when you get an intermediate value theorem problem, you have to say that f is continuous. Therefore, the intermediate value theorem applies. So here we're going to be like, not necessarily continuous. They didn't tell us it wasn't continuous, but they didn't tell us it was. So not necessarily means we're uncertain, cannot be applied. And then we'd say there may not exist a value of c in the interval. And c is an x value, right? So our interval is going to be this x interval from -1 to 3, where f of c equals 2. So not necessarily continuous is what we're going to pick, because it doesn't tell us either way. We're uncertain. But that tells us that we cannot apply the intermediate value theorem unless we know it's continuous. And then there may not exist. Again, we're uncertain. And then our interval matches our x values here. So this is just a little bit of practice to get you familiar with using the theorem and also checking to see whether the theorem applies.